Your production FastMCP server needs Azure authentication that survives restarts, but you don't want to sacrifice security for persistence. We'll implement a production-grade setup using encrypted Redis storage for OAuth tokens, combined with JWT signing keys to maintain sessions across server restarts. Here, how to configure it with minimal code while keeping credentials secure.
Import AS. From FastMCP, import FastMCP. From FastMCP Server Auth Providers Azure, import AzureProvider. From key value, AO stores, Redis import RedisStore. From key value, AO, wrappers, encryption import Fernet encryption wrapper. From cryptography, Fernet import Fernet. Hash production setup with encrypted persistent token storage. Auth provider equals AzureProvider. Client ID equals 835F09B6-0F0 F40CC85 CBF32C 5829 A149. Client secret equals your client secret. Tenant ID equals 08541B6E646D43 DA0 EB 834E6713D6D5. Base URL equals https://yourproductiondomain.com. Required scopes equals your scope. Hash production token management. JWT signing key equals OS. Environ JWT signing key. Client storage equals Fernet encryption wrapper. Key value equals RedisStore. Host equals OS. Environ Redis host. Port equals int OS. Environ Redis port. Fernet equals Fernet. OS. Environ storage encryption key. MCP equals FastMCP. Name equals production Azure app. Auth equals AuthProvider.
This demonstrates the OAuth proxy pattern combined with secure credential management for production-grade authentication. The code bridges Azure's traditional OAuth implementation with FastMCP's authentication requirements, using a dedicated provider to handle token validation and user identity mapping. What makes this distinctive is its separation of authentication logic from application code, allowing you to treat Azure authentication as a configurable component rather than embedded logic. The pattern works by delegating authentication to a specialized provider that handles the OAuth flow, token storage, and validation. The provider manages the entire lifecycle, initiating authentication, validating tokens against Azure's requirements, and securely storing credentials in encrypted persistent storage. This creates a clean separation where your application code remains unaware of authentication specifics, while the provider handles all security concerns, including token encryption at rest and secure session management. This approach matters because it solves the production challenge of securely managing OAuth tokens across server restarts while maintaining compliance. By externalizing authentication to a configurable provider, you avoid embedding sensitive credentials in code and gain the flexibility to swap authentication methods without changing application logic. The encrypted Redis storage ensures tokens persist securely between deployments, while the provider pattern keeps your main application focused on business logic rather than authentication plumbing. Let's break it down line by line.
Import AS.
Imports Python's AS module for environment variable access. This enables secure configuration by pulling sensitive values like encryption keys and Redis credentials from environment variables rather than hard-coding them.
From FastMCP, import FastMCP.
This imports FastMCP, the core framework class for building AI-callable tool systems. It handles authentication, tool registration, and request routing between Python functions and AI models.
From FastMCP Server Auth Providers Azure, import AzureProvider.
This imports AzureProvider, FastMCP's authentication handler for Microsoft Entra ID. It manages OAuth flows, token validation, and scope enforcement for production Azure AD integrations.
From Key Value, AO Stores, Redis import RedisStore.
This imports RedisStore, a persistent key value storage backend. It handles token storage across server restarts, preventing users from re-authenticating unnecessarily.
From Key Value, AO, Wrappers, Encryption import Fernet encryption wrapper.
This imports Fernet encryption wrapper, a transparent encryption layer that automatically encrypts all stored tokens before persistence and decrypts on retrieval. It defeats the risk of sensitive data exposure in storage while maintaining the same simple key value interface. The wrapper pattern here keeps encryption logic separate from storage implementation, making it easy to swap either component.
From Cryptography, Fernet import Fernet.
Imports Fernet from Cryptography, the symmetric encryption standard for token storage. This handles secure encryption-decryption of sensitive data before it reaches Redis, preventing exposure of raw credentials.
Hash production setup with encrypted persistent token storage. Auth provider equals AzureProvider.
This initializes the Azure Authentication provider for production, handling OAuth flows with Microsoft's identity platform. The provider manages token acquisition, refresh, and validation, ensuring secure API access without exposing credentials in each request. All subsequent FastMCP tool calls will use this centralized auth configuration.
Client ID equals 835F09B6-0F0 F40CC85 CBF32C 5829 A149.
This is the Azure Application ID, a unique identifier for your app registration in Azure AD. It authenticates your application to Microsoft's identity platform, enabling OAuth 2 flows for token acquisition. Always keep this value secure, as it's tied to your production credentials.
Client secret equals your client secret.
This is the Azure AD client secret for server-to-server authentication. It proves your application's identity to Microsoft's identity platform, enabling secure token acquisition. Never commit actual secrets to version control, use environment variables or secret managers in production.
Tenant ID equals 08541B6E646D43 DA0 EB 834E6713D6D5.
The tenanted specifies your Azure Active Directory tenant, which defines the organization boundary for authentication. This ensures users can only authenticate against your specific Azure AD instance, preventing cross-tenant security risks. Required for all Azure OAuth flows to properly scope permissions.
Base URL equals https://yourproductiondomain.com.
Sets the base URL for Azure Authentication redirects. This ensures all OAuth flows return to your production domain, preventing security issues from mismatched redirect URIs. Required for production deployments to maintain session integrity.
Required scopes equals your scope.
This defines the OAuth scopes required for API access. Each scope represents a permission level, and Azure enforces these during token validation to restrict what the authenticated client can do. In production, replace your scope with your actual API's scope identifiers from Azure AD.
Hash production token management. JWT signing key equals OS. Environ JWT signing key.
This sets the JWT signing key from environment variables, ensuring secure token generation in production. Environment variables prevent hardcoding secrets while allowing rotation without code changes, following the 12-factor app pattern for configuration management.
Client storage equals Fernet encryption wrapper.
This wraps the token storage in symmetric encryption using Fernet, preventing exposure of sensitive tokens at rest. The pattern combines persistent storage with encryption, ensuring security without sacrificing session continuity.
Key value equals RedisStore.
This instantiates RedisStore, a persistent key-value storage backend. It handles token caching between sessions, eliminating repeated Azure authentication requests. The Redis connection details come from environment variables for production security.
Host equals OS. Environ Redis host.
This pulls the Redis server address from environment variables, not hard-coded values. Environment variables keep sensitive infrastructure details out of code, enabling secure configuration across different deployment environments.
Port equals int OS. Environ Redis port.
Converts the Redis port from environment variable string to integer. Environment variables are always strings, but network ports require integers, so this ensures type safety before connection. This closing parenthesis terminates the Fernet encryption wrapper instantiation, completing the token storage configuration. It finalizes the nested setup, where Redis handles persistence while Fernet provides encryption, ensuring secure token management in production.
Fernet equals Fernet. OS. Environ storage encryption key.
This initializes Fernet symmetric encryption using an environment-stored key. It ensures all tokens in Redis are encrypted at rest, preventing exposure if the database is compromised. The key comes from storage encryption key in environment variables, following the 12-factor app pattern for secrets management. This closing parenthesis terminates the AzureProvider configuration block, finalizing the production-ready authentication setup with encrypted token storage. It ensures all required parameters are properly contained before being passed to FastMCP. This pattern of nested configuration objects is common in infrastructure as code setups. This closing parenthesis finalizes the AzureProvider configuration. It locks in all authentication parameters, token storage, and encryption settings, creating a production-ready AuthProvider instance for FastMCP.
MCP equals FastMCP. Name equals production Azure app. Auth equals AuthProvider.
This instantiates the FastMCP server with production-grade Azure authentication. The AuthProvider we configured earlier handles all token management, encryption, and scope validation, while the name identifies this instance for logging and monitoring. This is the entry point where your AI-callable tools get exposed to the configured authentication system. Production-grade authentication pattern. This AzureProvider configuration demonstrates FastMCP's enterprise-ready authentication stack, where sensitive tokens persist securely across restarts through encrypted Redis storage and JWT signing. The Fernet encryption wrapper is mandatory for production. Without it, OAuth tokens are stored in plain text, violating security best practices. Always derive your encryption keys from environment variables. Never hardcode them in configuration files.
The token that never touches memory becomes the most persistent.